Hi everyone. So today we are moving on to our next lesson, and that is going to be about modeling proportions. So for this particular topic, we will be solving proportions and also solve problems using proportions. So first thing, let's start with the word ratio. So ratio compares two quantities by division. So you can write ratios into two different ways. You can write it using a colon in between the two quantities, or you can write it like in fraction form. Now, one thing that is important when you are writing a ratio is that when you write these numbers, whichever form you use, you have to follow the order of the quantities that were mentioned. So let's have, for example, this one. A group contains 60 women and 30 men. The ratio of women to men, all right, is what? So since we mentioned the women first as our first quantity, then we will be writing 60 representing the women first. And then if you're going to use the colon, it's going to be 30 for the men, all right? Or if it is in fraction form, it's going to be 60 over 30, okay? Now, just like fractions, we always simplify in lowest terms our ratios as well. So in this case, you can see that both 60 and 30 could both be divided by 30. So this means that we can rewrite 60 is to 30 as 2 is to 1. And you can also see that as 2 over 1. Now, we do not simplify it as a whole number because we are talking about two quantities. So what does this mean? For every two women, there's always one man corresponding that will compose of the group. All right. A proportion, on the other hand, is a statement that shows two ratios are equal. So just like how we mentioned earlier about ratios, the important part of ratios is that the quantity should be in order by order based on how it was mentioned in the problem. In the case of proportion, whenever you have the ratios, okay, so they are equal. Let's say quantity 1 was mentioned first over quantity 2, then another ratio should also be mentioned. When you write it down, it should be in quantity 1 over quantity 2 representation as well to make sure that the statements are equal. Now, when you are missing one of the parts of a ratio, we use the cross product principle wherein if you have A over B is equal to C over D, the product of A and D is just the same as the product of B and C. That's why it's called cross product. So let's have this example. 63 is to X is equal to 7 is to 5. So if we are going to be solving, if we're going to be solving for the value of X, so we use our cross product technique. So we have X times 7, that is going to be 7X. And then we will have the product of 63 times 5. All right. So this will now be 7X is equal to 63 times 5 is going to be equal to 315. And now solving for X, we can divide by 7 on both sides. And therefore, X is equal to, if you divide 315 by 7, the answer is 45. Okay? So, Miss, is there a way that I don't need to do some computation like this? Yes, there may be, but this is not always a scenario, okay? In our case here, if you take a look at our given, we have 63 is to X, and then the other ratio is going to be 7 is to 5. If you observe the pattern, the first quantity is 63, and then it became 7. So try to think, from a 63, what number can you multiply or divide to get a 7 from 63? So if you think of it, if you divide 63 by 9, the answer is going to be 7. So if you think about that, what number, if you divide by 9, will give you 5? And in that case, using your multiplication facts, you know that the number 45, if you divide by 9, will be giving you a 5. So in this scenario, if you notice that that pattern exists, you don't need to do the cross product. But in most cases, like in the example here below, and in this next example, you cannot do that mental math right easily. Sometimes you will have expressions on both sides, all right? And so it's better to use your cross product technique. All right, so let's move on to our next example. Let's have 20 over x minus 10 is going to be equal to 30 over x. Now, as you can see here, 20, can you multiply or divide a number to make it a 30? There's none, okay? So you cannot see that pattern right away. So we have to do our cross product. So in this case, this is going to be 20 times x, which is 20x, is equal to 30 times the expression x minus 10. Now, as always, when we are solving equations, make sure that we start with distribution. Okay, is there anything that we can distribute? Yes, it's the 30 that needs to be distributed to this expression. So this is now 20x is equal to 30 times x, which is 30x. And then 13 times negative 10, that is negative 300. And now if we're going to move, we want our next step to be combining like terms. We want all our x's on the other side of the equation. And so we will be moving negative 30x together with here. So this is minus 30. So that is gone. Minus 30x. So as you can see here on the left side, we have a negative 10x is equal to negative 300. And solving for x, we divide by negative 10. We divide by negative 10. And so x is equal to 30. All right. So does that make sense in here? Let's see. If you check our example, so 30, this is our x, right? 30 minus 10 is 20 over 20. Is that the same as 30 over x, which is 30 over 30? And you can see that the two ratios are going to be equal to each other. Okay. So now, how can we use proportions when solving word problems? Well, typically, we always read a problem and make sure that we identify the two quantities, all right? Now, when you set up your equation using the proportion, you have to be consistent. Order of quantities, when you write it down, needs to be consistent. On order of quantities is important, okay? So when you have, let's say, girls over boys, then in your second ratio, it should be representing the number of girls over boys as well. All right? So let's have this example. The property tax on a house with an assessed value of $480,000 is $5,760. Determine the property tax on a house with an assessed of $600,000, assuming that the $600,000, assuming same tax rate. All right. So in this case, what are we looking for? We are looking for the property tax. So X is our property tax. Okay, because as you can see here, determine the property tax. All right. Now, we need to set up the proportion. Now, what are the two quantities that are being compared? We have the property tax and also the assessed value. Okay? So you can have it as property tax over assessed value of house number 1, okay, is going to be equal to the property tax of house number 2, tax of house number 2 over the assessed value of house number 2, okay? So this is what I am talking about, having consistent order of your quantities. So property tax, assessed value, property tax, assessed value. So now we can put in those numbers, okay? We got to make sure that we put in those values in the correct positions here. So if you're going to take a look here, property tax number 1 is which one, okay? So property tax is 5,760. So this is 5,760, all right? The assessed value of the first house is 480,000. Okay. The property tax too, that is the one missing. So we can replace it with the X because the second assessed value, all right, as you can see, is 600,000. All right. So from here, you can solve your problem already. So again, that's going to be 5760 over 480,000 is equal to X, which is missing 600,000. So if you do your cross multiply, you will have 480,000 X is equal to, you multiply 5760 and the 600,000. All right. And if you do that, you will have 480,000 X is equal to, if you multiply 5760 and 600,000, that's going to be 3,456,000, okay? And how do we solve for X? Now remember, we always divide. I'm sorry, I don't have enough space. So we divide by 480,000. Divide this whole thing by 480,000. And so the X is going to be equal to 7,200. Okay, so you just use your calculators to work this out. And as you can see, the X is going to be 7,200. Therefore, the property tax on a $600,000 house is equivalent to 7,200. So that is how you can make sure that you got the correct answer. Okay. All right, let's have a second example here. Same scenario. This time it's a sampling in nature. So there is what we call as the capture-recapture method, wherein the wildlife population could be determined based on the number of picked out, or so they were like labeled or tagged, and then that's the total number of population of the animals. And then when you get a sample, you check the number of the recaptured animals, and then you also compare it with the population. So if you will notice here, we are looking at, so this ratio here are the original, okay? The original numbers. So it's always tagged over population, okay? So that will always be the order of our ratio. In this case, this is your sample, okay? So this is your sample, that is, so the ones that you have picked out, so tagged over population as well. So let's take a look here. So we have a wildlife biologist catch, tag, and then release 135 deer back into the wildlife. 2 weeks after, they observe a sample of 140, 30 of which are tagged, okay? Assuming the ratio of tagged deer is the same for approximately how many deer are in the refuge. So in this case, again, we follow our pattern. So the original number and then the total number of population. So in this case, what numbers are we going to be using to replace? So we have the original number of animals. So that is 135. Those are the tagged, okay? See here, catch, tagged, and then release. So the original number of tagged is 135. Oops, sorry. We do not know how many all in all is there. So that's the X. How many animals were recaptured according to this one? We have a total of 130 of the recaptured animals are tagged, and then there's a sample of 140 animals that were recaptured all in all, okay? So 30 were tagged out of this sample. So our equation, sorry, our proportion will look like this. And so if we solve for it, so we will have 30x is equal to 135 times 140, and you will be getting 30x is equal to 18,900, and solving for x, you divide by 30, x is going to be equal to 630. So 630 was the original number of deer that was in the refuge. Okay, so that is the total number of deer in the refuge. Thank you.